All right, so this is the last day of notes for this chapter. So we're doing day 8. On your notes, it'll say 11.9. That's the section that it comes from in the book. We are going to review for 2 days, and then the test will be on Thursday of this week. Okay, I will not be here, so I can't meet you before school or meet you fourth hour or anything like that to study. So if you have questions, you need to make sure you're asking them during the review days tomorrow and Wednesday. I have no idea who this sub is. No idea who this sub is. All right, quick review. How would you do the first one? You double distribute. So we're going to do C times C, C times negative D, D times C, and D times negative D. And you end up with this. C squared minus CD plus CD minus D squared. What happens to the CDs in the middle? They are going to equal 0 CD, which is just 0, so you don't need to write it. So this is a dots, difference of squares. C squared minus D squared. What are your questions?
That was unnecessary.
All right, number 2. How do you do that one?
X plus y, x times x plus y.
Yeah, you need to rewrite it so that you have x plus y twice. You cannot just square the x and square the y. That absolutely does not work, okay? You have to write it twice, and then you double distribute. So we're going to do x times x times y times x, y times y. Okay? Then what? Yeah, so in the middle, that's 1xy plus 1xy, which is 2xy. What are your questions?
Will we have to solve this?
What do you mean when you say solve this?
It's already
It's already
solved.
solved. Never mind.
None of those things.
I meant something else. I just can't think of
Yeah, I'm not sure what you mean either. We're just multiplying it out.
I meant, is there any way to simplify it further?
No, that's it. All right, next one you just distribute. That's a single distribute problem. So 8x times x is 8x squared. 8x times negative 7 gives us the minus 56x. And then what would happen on number 4? Another double distribute. So 3w times 2w would be 6w squared. So plus 3wt minus 10wt minus 5t squared. And then what's 3wt minus 10wt?
Negative 7wt.
Very good. So I end up here. So we're going to be doing this same sort of thing today, multiplying. However, we'll have some radicals involved. So you got to remember your rules for distributing and double distributing and your rules for radical multiplication. And then adding and subtracting radicals when you have them that are alike after you double distribute. So it's kind of a lot of previous topics all coming together. What are your questions? All right. Here's example 1, part A. Mm-hmm. All right, so I have 2 binomials. They're being multiplied by one another, so I am going to double distribute. So 5 gets multiplied by the 5. That's 25. Okay, then we'll do 5
Minus 5. Square root 7.
times the square root 7. One's outside a radical, one's inside, so you just leave it minus 5 square root 7. Now I'm going to distribute the square root 7. So positive square root 7 times 5 is plus 5 square root 7. And then in the back I get
60. Square root 64.
40, square root 49.
My fault.
Yeah, and what's the square root of 49? 7. So you can just make it a regular 7. Okay. Now, what happens? Shh. What happens to the terms in the middle?
They add together. No. Yeah.
It turns into an A, right?
Yeah, it's going to give you 0 square root 7, which is just 0. And now, since we actually found what the square root of 49 is, look, these are just regular numbers. So you can do 25 minus 7, which is 18. All right, what are your questions? Yeah, so I'm going to have to double distribute, but what do I have to do first?
Write it out twice.
Rewrite it twice. Good. So this is 4 plus square root 6 times 4 plus square root 6.
Is there a specific name for what that's called? Writing it out twice. If you see
I don't. Just writing it twice. It's a binomial squared. What's up?
What did the exponent cancel out the square? Square out the.
You can't just square both of these terms. You can't just, it's not like 4 squared plus this squared. You actually have to write it out twice.
Oh, I thought it just changed the 4 to a 16 and made this 6.
That's what I was just saying absolutely did not happen. No, you have to write it out twice and double distribute. That's okay. All right, so I'm going to distribute the 4. 4 times 4 is 16. 4 times square root 6 is 4 square root 6. Then you get a 4 square root 6 again, because now you distribute the square root 6 to the 4. And then we're going to have square root 6 times square root 6, which is square root 36. And what's the square root of 36? 6. So you can just write plus 6. So yeah, what you were saying, doesn't the square root and the squared, don't they undo each other? They do, but not in this step. You have to wait till you're down here and you're multiplying them together.
Okay.
All right. Now, I can actually add
0.
the 0. What are you talking about?
There's 0 in the middle.
They're both positive.
Oh.
No, you would get a 0 in the middle if one of these was, if it was a difference of squares, if one was a plus and one was a minus. That's not the case here, though. So I can actually add the terms in the middle because they have the same radical. I can add the terms on the outside because they're both just regular old numbers. We call them constants.
22 plus 8 square root 6.
So yes, you're going to get 22 plus 8 square root 6. And you're done. You can't make it like a 30 square root 6 because the 22 does not have a radical, but the square root 6 does. Questions? Very good. So we have a binomial squared, so I'm going to need to rewrite it twice. Then I can double distribute.
Wow. That's a lot.
So 3 square root 3 times 3 square root 3. So what is 3 times 3? So the 3's on the outside will multiply together. That gives me 9. What's the square root of 3 times the square root of 3?
3.
It is 3, because you get the square root 9, and then it's 3. So you can just go ahead to this step if you want. If you want a step in the middle, it would look like this, 9 square root 9. But we know that the square root of 9 is 3, okay? So if you want to write this step, go for it. If not, go right to there. All right, and then I'll do square root 3 times the square root 10. The 3 on the outside doesn't have anything to multiply with, but the 3 on the inside can multiply by the 10 to give you square root 30. Now you're going to distribute the square root 10. What's square root 10 times square root 3? Square root 10 times 3 square root 3. I keep dropping the 3's. Yeah, it's another minus 3 square root 30. And then in the back, what happens? Square root 10 times square root 10 is square root 100, which is 10. And will I be adding that or subtracting it? Adding, because it's a minus and a minus. Okay? Now, take a minute and look at what's on the board, because a whole lot happened in one step.
Negative 3 square root 30 plus a minus 3 square root 30.
All right. Do you know where each term came from?
Yeah.
All right. Now, I can go ahead and start combining like terms, and I still need to do the 9 times the 3. So that's going to be 27, and then those are like terms. They have the same number in the square root. So negative 3 square root 30 minus 3 square root 30 is negative 6 square root 30. Up front, the 9 times the 3 made a 27. And now I can combine the 27 and the 10. So what do I get? 37 minus 6 square root 30. Very good.
That's a lot of work.
It is a lot of work. What are your questions? So let's start double distributing. So I need to do 5 square root 3 times 5 square root 3, which would be... Okay, yeah, so it'd be 25 times 3, right? Because 5 times 5 is 25. Square root 3 times square root 3 would be square root 9. And the square root of 9 is 3. So you're right. Eventually we'll get 75. All right, what's 5 square root 3 times 2 square root 6?
10 square root 18.
Yes, so plus 10 square root 18. And then here it's the same thing but with a minus. So minus 10 square root 18. And then in the back, I have negative 2 square root 6 times positive 2 square root 6. So it's going to be a minus. What's 2 times 2? 4. And then what's square root 6 times square root 6? 6. So minus, and then I have to do 4 times 6. All right, so those middle guys are going to go away, right? They're the same exact thing. One's a plus, one's a minus. Up front, I can do the multiplication. I get 75. In the back, I can do the multiplication. I get 24.
So 51.
And then you get 51 as your final answer. Very good. All right. Example 2, part B. What should I do? Double distribute. What is 7 square root 5 times 2 square root 5?
Yeah, I got that.
14
Square root 25.
square root 25, but what's the square root of 25? 5. It's going to be 14 times 5. And then I have to do the 7 square root 5 times 6, which would be minus 42 square root 5. Then I'm going to distribute the 11. So 11 times 2 square root 5 would be 22 square root 5. And in the back, what's 11 times 6?
66.
Minus 66. Good. So in the middle, I have like terms, right? They're both square root 5, square root 5. I can also take care of the 14 times 5. So, yes. Yes, so 70, combine those, you get minus 20 square root 5, and then I still have the minus 66. So final step would be to get these two guys together.
4 minus 20 square root.
4 minus 20 square root 5. What are your questions?
Square root 5. Oh my God.
All right. Now, we're going to use one of the tricks that we just sort of witnessed to get rid of the radical in the denominator. So, are you ready to see a new trick?
No.
I cannot leave a radical in the denominator.
Oh yeah, you got
Correct?
multiply it by the bottom.
So, if I multiplied the denominator by the square root of 3, let's just say I'm like, let's try it. Don't write it out because it's not what you do actually. But if you were going to multiply by the square root of 3, you'd have to multiply both terms by the square root 3. Would that get rid of all the radicals in the denominator?
No.
No, because now we'd have one up front with the 3. See what I'm saying? So we're going to use that idea of the dots to get rid of the radical. This is called conjugate multiplication. It's the exact same thing, but with a different sign. So if you have one term, you can just multiply what's in the radical. If you have two terms, you're going to multiply by the same thing that's in the denominator, but with a different sign, and I'll show you why. Because when you double distribute, see how we'll get 9? And then we'll get the same two terms in the middle. One gets a plus, one gets a minus. And then in the back, we'll have the square root 3 and the square root 3, which would get rid of the radical. So again, this is that trick if you have more than one term and you're trying to get rid of the radical. Okay? And I'm going to fill in that missing step to show you why. Because this would be 9. And then you'd get plus 2 square root 3. And then you'd get, it'd be plus 6 square root 3. But then you'd get minus 6 square root 3. And then you'd get a minus 2 times 2 is 4. And then square root 3 times square root 3 is square root 9, which is 3. Okay, so this is the middle step that's not shown. They kind of jump to the important part, but that's how we get from here to there.
So do we gotta do that part?
If you know why it's 9 minus 12, you don't need to show me that middle step. I'm just showing you why it works. All right, and up top we distribute the 6, so 6 times 3 is where the 18 came from, and then in the back we have 12 square root 3. All right, I'm going to stop here for just a second because once I click the next button, that part will go away.
9 minus 12.
All right, so 9 and 12, those are both constants without a radical. No variable. You can combine them. That gives me 3. Now here is the other part where this gets tricky. Do you see how negative 3, or just regular 3 for that matter, goes into 18?
Yeah.
Do you see how it also goes into 12?
Yeah.
Do you see how none of them are in radicals?
Yeah.
So we can actually simplify. If every number up top that's outside the radical,
Negative 6.
each term is divisible by the number in the denominator, you can go ahead and divide them.
Negative 6.
So 18 divided by negative 3 is negative 6. 12 square root 3 divided by negative 3 is minus 4 square root 3. What are your questions? All right, what is the problem?
We have to divide
Same
on
thing.
the denominator.
Yeah, you can't have a radical in the denominator. So do you remember the trick?
Yeah.
Times it multiplying.
Yes, so what am I going to multiply by?
4 minus
4
plus
2 square root 7.
Yeah, 4 plus 2 square root 7, top and bottom.
What? Wait, whoa.
They just changed it.
That's the trick. You change the sign so that when you double distribute, the middle terms will go away. It's like dots. All right. So up top, what's 2 times 4? 8. What's 2 times 2 radical 7? 4 radical 7. Good. Now down at the bottom, 4 times 4.
16.
What's going to happen to the middle 2 terms? They're going to go away. So in the back, I'm going to have a minus. What's 2 times 2?
4.
And what's square root 7 times square root 7? 7. And what's 4 times 7? 28. Any questions? Take a minute. Let that soak in how we got from one to the next.
Oh, man, I'm slow. You all have my numbers.
You have your moments every day.
All right. What can I do next?
Simplify the denominator.
Yes, I can combine like terms in my denominator, which would give me
Negative 12.
negative 12. Now, check out each term and see if we can do a little simplifying. So the 8 and the 4 and the 12.
Divide by 2.
You can do a little better than that. Yes, each of those is divisible by 4. So I can go ahead and simplify. 8 divided by 4 is 2. 4 square root 7 divided by 4 is 1 square root 7. And then negative 12 divided by 4 is negative 3. And that is my answer. Raise your hand if you have any questions. All right. Here is example 5. Yes.
I want to say the 2's and the square root 5's cancel out, but I'm pretty sure that's wrong.
Nope.
Do we do the thing again?
Yes, we have to do the thing again. So what am I going to do?
2 plus
2 plus
square root 5.
Yes, I'm going to multiply top and bottom by 2 plus the square root of 5. Now, up top,
4.
you'll get 4. And then plus 2 square root 5 plus 2 square root 5 plus 5. And then in my denominator, 2 times 2 gives me the 4. The middle terms will go away. One will be a plus, one will be a minus. I'm not even going to write them. Square root 5 times square root 5 is square root 25, which is 5.
Thank you.
Now, in my numerator, I have 2 sets of like terms. What am I going to end up with?
4
9 plus 4 square root
9 plus 4 square root 5 over negative 1. Do you think I leave it like that?
Yeah.
No, you can just change the signs and then you can eliminate the denominator. What are your questions? All right. What shall I do?
Conjugate multiplication.
Very good. So what should I multiply the top and bottom by?
3 minus square root.
3 minus square root 11. So 3 times 3 gives me 9. Minus 3 times square root 11 is going to be 3 square root 11. In the denominator, 3 times 3 is
9.
9. And then I'm going to have minus 3 square root 11 plus 3 square root 11. Those are going to go away. And then in the back, I have minus the square root of 121, which is regular old 11. All right, in the denominator, those are like terms now. They're both just constants. What is 9 minus 11?
Negative 2.
Negative 2.
No.
No, so the 3 has a square root 11 with it. The 9 does not. So those cannot be subtracted. All right. Questions? Okay, what did we learn about today? I'm okay with that. Radicals. Specifically multiplying binomials and using conjugate multiplication. But again, we can shorten a little bit. Radicals or radical multiplication might be a better way. All right, so we have finished the chapter. That's all you're going to learn.
Yes.
I will give you your homework and then plan on a couple days of review and a test before the end of the week.